Okay, Professor Jim Schultz here from my Finance 680 class. I wanted to go ahead and shoot my first video for this third section of the class. I thought the first problem I would go through is a problem that's been pretty popular in previous semesters in terms of students wanting to see this one worked out. And so this is number 24 from chapter 13, and you can see I already have my solution here up on the screen. I do not have my textbook with me. I'm at home and my textbook is at my office, and so I can pretty much remember most of this problem though from memory. And so basically this problem, the way this problem is set up is you have a table and you have to fill in the table with various weights and dollar amounts essentially. And so the problem tells you that you have these four different investments. You have A, B, C, and the risk-free rate. And it basically tells you that your combination of these four investments is going to have a beta that has the same risk level as the overall stock market. And so from that information, you can deduce that your portfolio beta, or beta sub P, has to be equal to 1. That is a critical piece of information that you have to figure out, otherwise you cannot solve this problem. And then the other important piece of information that you'll see comes in handy here in a minute is that the beta of a risk-free asset is going to be 0. Essentially, because by definition it is risk-free, and so its beta or standard deviation would be 0. And so basically, to proceed with this problem, you're essentially going to set up a weighted average across the various betas that you're given. You're given the beta of A, B, and C respectively, and here they are at 0.85, 1.2, and 1.35. And you set this guy up, and you're given the dollar amounts of A and B, and you have a $1 million portfolio which you're also given. And so you can figure out the weights for A and B. And so A goes in there, B goes in there. And then it appears like you have one equation with two unknowns where you do not know the weight of C and you do not know the weight of risk-free. But the great thing about this piece of information with the beta of a risk-free asset being 0 means that obviously anything multiplied by 0 is going to come out to be 0. And so this guy is going to drop out of our equation, which we see happening down here, right? So I fill in the weights that I know. This is 21%, 32%. I don't know the weight of C. That guy's going to drop off to 0. And so then you're left down here with only one unknown in the equation. And you can solve for W sub C, comes out to be 32.41%. And so then what you can do is you can just plug that guy back in with the other two weights that you have. So you know that your weight of A is 21%, your weight of B is 32%, and your weight of C is 32.41%. And so you know that the weight of all four must sum to 100%, so the weight of your risk-free has to be whatever is left, or 14.59%. And from there you can quickly collect the dollar number for each one, because you know you have a $1 million portfolio, so 32.41% of $1 million is $324,100. And then obviously for the risk-free asset you have $145,900. And so this is how you solve number 24 from chapter 13.